Hello everyone. In this video, we will see how we can select a suitable size of a cable for our project. In the beginning, let's understand what to consider when selecting and calculating the size of a cable. Well, we have to consider two major things. First is the load current, and second is the derating factors. I think most of us know already what is meant by load current, but let's understand more about what is meant by a derating factor or derating factors. They are the factors that may affect the cable's ability to withstand the rated current. In other words, these factors are the ambient factors that will decrease the efficiency of the selected cable. These derating factors include ground temperature, air temperature, burial depth, soil thermal resistivity, and grouping factor. Let's understand more how these factors might negatively impact the cable's efficiency by looking at this example. The example says calculate the overall derating factor for three cables of this type, spaced 15 centimeters from each other, buried 1 meter underground at a temperature of 55 degrees Celsius. So we are given a cable type of copper inductor, XLP insulation, steel wire armament, and PVC sheath. A ground temperature of 55 degrees Celsius, burial depth of 1 meter, and a grouping factor of 15 centimeter between each cable. So we are having here some values, 0.8, 0.93, 0.78. So where do we really get these values from? To get these values, we have to check a catalog or any cable's catalog and get these values from the derating factor tables. Let's have a look on this catalog, for example, and check the tables. Right, so starting from this page over here, or this section, we will have the tables that include different derating factors. First derating factor here is the ground temperature. So in the example, we are given a ground temperature of 55 degrees Celsius, and our cable type is an XLPE type. The derating factor for the ground temperature will be 0.8. We don't have something in air temperature or anything that indicates what is the air temperature, but we have the burial depth. So the burial depth is at 1 meter underground. And if we assume that the cable size is between 95 to 240 mm squared, so the factor will be 0.93. Let's look at more derating factors. We are not given any information about thermal resistivity, so we can just pass this table and look at the tables that are given in the example. We are comparing what is given in the example with these cables. We are given also the spacing between the cables. This table says that this is the formation derating factors for multi-core cables. So exactly this table what we need. So we assume that we have three cables that are spaced 15 centimeters from each other. And let's also assume that these cables are placed in a flat form, 15 centimeters. So we will look at this part of the cable. And we have three cables, so the value will be 0.78. Now let's get back to our example. So to get the total derating factor or the overall derating factor, we will multiply all these values together and get overall derating factor of 0.56. This is what we need to know about the derating factor. Now let's conclude these steps for selecting a size of a cable. So these steps include first step of calculating the load current. Second step is to multiply the load current by a safety factor of 1.25 to obtain the I circuit breaker or the current or the rating of the circuit breaker. And the third step is to divide the I circuit breaker by the derating factor to get the I cable. And finally, the last step is to select the suitable cable using the obtained I cable value. Of course, to apply these steps, we are going to use some formulas. These are the formulas that we are going to use when selecting a cable. First formula indicates the current of the load, which equals power in watts divided by root 3 or 1.732 multiplied by the voltage multiplied by the power factor. And this formula is for a three-phase system. For a one-phase system, the current formula will be power in watts divided by voltage multiplied by power factor. Then this formula is the I circuit breaker. So the obtained current from the one-phase current or the three-phase current will be multiplied by 1.25, which is a safety factor. And finally, the I cable or the rating of the cable will equal I circuit breaker divided by the derating factor. Let's now have a real example on how to select a cable size. So we are given a DB load or a distribution board load of 25 kilowatts, three-phase system, and we are asked to calculate the cable size and the circuit breaker rating. And in taking in consideration that the cables will be installed in a cable tray, and we are given power factor of 0.8, voltage is 415 volts, and the rating factor of 0.8. So as we said, the first step is to calculate the current, which equals the power over root 3 into voltage times power factor, and we will get this value, 43.5 amps. Then the second step is to obtain the I circuit breaker by multiplying this value by 1.25, which is the safety factor, and we will get 54.4 amps. Then we have to select a suitable size for our circuit breaker. So we will go for either 60 or 63 amps, depending on the available circuit breaker ratings in the market. So in some countries 63 amps are available, some countries 60 amps are available, so it depends on the market. The third step is to obtain the I cable by dividing the I circuit breaker by the derating factor. We already have the derating factor of 0.8, and the circuit breaker, for example, we chose a 60 amps, so we will divide 60 divided by 0.8 to get a 75 amps. So this is the important value. Going to look for a suitable cable size according to this value. Now, if the derating factors are not known exactly, we can take it as 0.8. Another thing to consider here, you may ask why when calculating I cable, we divided the I circuit breaker, which is the 60 amps, and not the load current, the 43.5 amps. Well, it's always preferred to select a cable that can withstand maximum current. Simply, to select a bigger size cable is always better, because maybe in the future this DB or distribution board will supply additional loads, so there will be no need to replace the cable with a new one. Also note that replacement of a cable is more difficult and could be more costly than replacement of a circuit breaker. So it is always better to keep in mind that in the future there may be additional loads. Also, keep in mind that if we didn't consider the derating factor, we might use a smaller size of a cable. Because as we said before, derating factors will affect the cable's efficiency to withstand the rated amount of current. For example, we can have a cable that can withstand 60 amps if installed in a cable tray, but if the same cable installed underground, it might not be able to withstand the same amount of current. So it's important to calculate the derating factors always. The fourth step now is to select a suitable cable based on the obtained I cable value using any catalog. Let's check the cable sizes using this catalog. Let's go to low voltage cables section, multi-core cables. If we are selecting this cable in a hot area, it's better to select an XLP insulation that can withstand up to 90 degrees Celsius temperature. And check this cable, for example, this is XLPE steel. We don't need any armoring because the cables are installed on cable tray. We might need the armoring of a cable if it's installed underground. Also, copper is better than an aluminum. So let's check this cable. It's copper conductor, XLP insulated, and PVC sheath. Now the value that we got, the I cable value is 75 amps. And this cable will be laid in air, and that is because it's on a cable tray. So it's not inside a duct or laid underground. So we will look at this side of the table, and we will look for 4-core cable, and this is because it's three-phase system which needs 3 lines or 3 conductors and 1 conductor for the neutral. So we will check at this section for core cables and laid in air, and the value that we have is 75 amps. The I cable equals 75. So 75 lies between 68 and 89. So instead of selecting less than 75 amps, we will select more than 75 amps. So this cable is 16 squared size cable. This means that this cable can withstand 89 amps if laid in air, 75 amps if it's in duct, and 97 amps if it's laid in ground. This means that this is the suitable size that we need for our DB. Now, if we go back to our slide and find that the answer is the cable size that we need will be of a 4-core into 16 millimeter squared of E-type copper conductor, XLP insulation, and PVC sheath.